champion. Alex, my colleague that was supposed to run this session, is sick, so I'm replacing him. So that's the bad news. The good news is that this content is part of our content. We are a group of developer advocates in Red Hat. So this is one of our topic that we run at conferences. So we're pretty flexible in delivering it. So you're losing Alex, Java champion, and you have me. I'm sorry about it, but the content is there, so don't worry about it. Hey, let me know if you have any question in the chat. I'll take a look also after the session. We have 45 minutes. And now let's go into the topic of today. My name is Natale Vinto. I'm a developer advocate lead in Red Hat. I'm leading this team of global developer advocates in Red Hat. Here you have my Twitter handle, my Mastodon handle if you want to contact me. And I'm book author for O'Reilly. I wrote 2 books, Modernizing Enterprise Java and with Marcus Eisel, and GitOps Cookbook with Alex. So Alex is my buddy, as you can see. And I'm also co-organizer of Kubernetes Community Day Italy. And this year I'm ambassador of CD Foundation to evangelize open source software for continuous delivery, continuous integration. I'm also a host at OpenShift TV, a web TV talking about OpenShift, Kubernetes, Cloud Native. Those books, you can download those books also in our Red Hat developer portal for free. I'll give you the link at the end of the session. But let's go into the topic. We have our session today, and we have some slides, and then we have also a demo showing this topic in action. So we know that if you are attending this session, you know that data streaming is the future, because anything is real time, is connected. Think about the use cases about IoT or cloud or telco. Anything is asynchronously transmitted, and there's a massive demand of those kind of services. So data streaming is really having a great momentum in the community and in the market. There's another approach or paradigm or methodology, if you will, that is really popular, which is GitOps. For those of you not aware of GitOps, GitOps is a methodology which is a kind of an evolution of infrastructure as a code, and goes into the pillar of having Git as the single source of truth. So it's like doing DevOps and using GitOps as an approach to put in Git anything and control anything with Git. We will see in a moment what this means, but I just wanted to set the context of this session on today. Data streaming and GitOps together. Now let's go into a typical use case when we work in our daily job, right? This is what we call the wall of confusion. This is a developer and an ops person, a developer person, and you know, there's this wall of confusion, and there are jokes between developer and ops, as you know. So how do we mitigate? How do we stop that? Well, one approach is to break those barriers and let the developers and the operation talk together and work together more closely. But how do we do that? We need process and we need technology. In this scenario, developer is the champion, and also the ops is the champion. Anyone is the champion here. And so let's see how we make those champions working collaboratively together. Creating value on what we do is in our ability to deliver application faster. So if we want to deliver application faster for cloud native application or AI machine learning workloads or data analytics, Internet of Things, right? We need to make this cooperation really in place. We need to let those champions working closely together. So without any barrier, if you think about. So how do we do that? First, let me tell you this: developer happiness is really important. It's not only me saying that. It's this study from McKinsey that was reckoning that there's a 100% cost reduction for operating infrastructure when the business focus on developer velocity, and it's 5 per faster revenue growth attributed to the developer velocity. So what is this developer velocity? It's just the ability for developer to be productive, to access the resource they need, and start coding and start testing and have a feedback loop, what we call the feedback loop. So that's very important. This leads to this cooperation between dev and ops I was talking to you about. But now let me introduce another object, which is the main focus of today, and it's Strimzi. A Strimzi is a Kubernetes operator which brings you Apache Kafka on Kubernetes. So we were talking how do we bring data streaming, how do we bring GitOps, how do we bring dev and ops collaboration, how do we bring developer velocity. Let's go into the more in detail into the infrastructure as a code approach, into the GitOps approach, in the Kubernetes native approach. If you want to be cloud native, we need to be container based, hopefully Kubernetes based. Kubernetes is a very popular platform orchestrator of containers, and when we want to run data streaming on in this platform, you can use Strimzi. So Strimzi is an open source Kubernetes operator that delivers Apache Kafka on Kubernetes. Why is important? Because it gives you the control to create Kafka at ease in this world. And how this is possible? Well, it's possible through some API that this tool brings. And for those of you not aware of Kubernetes operators, the Kubernetes operator are a pattern in Kubernetes where you can implement a stateful application, but also the whole life cycle of the application is controlled in the Kubernetes controller cycle. So it's very close to Kubernetes, but it's also a very powerful object in the hands of developers and ops. Why we are focusing on Strimzi today, and this comes also from one of our popular workshop on Kafka. You have the link in the bottom left of the slide. Strimzi is a Kubernetes implementation for Kafka, and has three main goal or advantage, if you will. It's secure by default because it comes with an opinionated setup that brings out of the box security, TLS, automated certificate management, something that is if not hard, is tricky to configure, is challenging, is difficult at scale. This tool gives this capability at scale. It's configurable. If you are a developer, you don't want to be a Kubernetes hacker, right? Or a YAML hacker, right? You just want to have your tool. In this case, I want Kafka, and I don't have to configure, I don't have to know anything about rack awareness or how to set up a load balancer myself, right? I just can set up something in the YAML file, and this will do the trick for me. And then it's Kubernetes native because it's a first-class citizen in Kubernetes. If you are familiar with Kubernetes, you will recognize this object. kubectl is the CLI. As you do kubectl get pods to get a list of running application in your cluster, running pods, you can do kubectl get Kafka. Very easy, very, very intuitive. Again, it's Kubernetes operator based, and it's ready, is cloud ready or GitOps ready. It's ready to be managed with the GitOps approach. We will see in a moment what this means. So let me show you an example of the deployment. Now, you want to create Kafka, right? You need you are a developer, and in your laptop there's some Docker Compose, Podman, something from your programming language that let you create at ease container, and you can use one Kafka container, right? But what about if you need to test this on Kubernetes, or if you want more production like setup. Like in one container of Kafka is just okay for a local development or just a kind of mock. But when you need to work with a real cluster and with 3 replica, how about you control with the code and you say, hey, I want Kafka, I want this version. Oh, this is a pretty old version, by the way. And I want 3 replica of Kafka, and those are my transaction state log replication factor, and this is my offset. And if in this case, this is here you have ZooKeeper, but if you don't want ZooKeeper, you can remove, and then you storage. You can set up ephemeral or you know, or storage space, or backed by a persistent volume or something. So you have the power to control this object, which is not a trivial object. Is a cluster, right? It has a state, need to be handled. But in this way, you are delegating this complexity to Kubernetes and to the operator, bringing the API to control the Kafka cluster. Now, why GitOps and what is GitOps again? Let me know in the chat if you were already using Kafka, you are already using any Kafka on Kubernetes, and if you are already using GitOps. But for those of you not really aware of GitOps, let's do a refresh. GitOps is a methodology that consists of 3 main pillars. The first pillar is this one. Git is the single source of truth. Any operation you need to do has to go on Git. I'll show you in a demo how this works. So any operation you do has to go in Git. The second pillar is you treat everything as a code. Not only the application, your app, right? But also the manifest describing your application. Also the security, the policies, even the Kafka cluster, anything is treated as a code. The third pillar is any operation is through Git. This is good for developer because developers are really aware, and Git is very common for developer, but also for ops, right? But for developer, it's very common. If you need to do a change, you do a pull request, somebody review this change and then approves. Here is the same concept. You need to perform a change in production. You need to add a group, a user. You open a pull request, somebody review it, and with the GitOps approach, then this is applied to the production or any environment you want to work with GitOps. Again, GitOps is a developer-centric approach to continuous delivery and infrastructure operation. But why GitOps? And we're getting into the core of this session. Well, it's a standard workflow. Developer, ops, and people are familiar with Git and Git workflow. So this is a standard workflow nowadays. Enhanced security. You can review change beforehand. If you remember, oh, I have to change something in production, I need to, maybe I'm running a command via SSH. No, that's not good. This needs to follow a process. And what about if the process is a pull request review? And in this way, you can also detect configuration drift and take action. Visibility and auditing, that's also very important. You can capture and trace any change to the cluster through Git history. Now, think about you have multiple endpoints, multiple cluster with multiple Kafka cluster for multiple environment. You can control everything from Git, and all the change are propagated then by a GitOps controller to your endpoint, to your cluster. But this is very good for visibility and auditing because you can trace and capture any change to the cluster through the Git history. As you do Git log for your app, you're gonna do Git log for the infrastructure. And to the point I was mentioning before, this enables multi-cluster consistency because you can in a reliable and consistent way, you configure multiple Kubernetes cluster and deployment. It's not only for Kubernetes, to be honest, this is valid for everything. Think about you have multiple cloud instances, and you are using GitOps to take them, have them in sync, right? And have consistency. There's no mistake, there's no drift between two environment because it's controlled by GitOps. So those were the main goals of having GitOps. Let me show you a typical GitOps application delivery model. And I think it's very common today that you have at least, one app, with one or more repo for your app. Let's say this app is a one only app, but if you have a microservice based application, maybe you have multiple repo. And then there's an automation creating from your app the artifact, the container image, and then you store this container image somewhere. I'm talking about container because it's a very popular and common format today to work with and to create app. But then let me show you the GitOps part, which is a Git workflow, a Git action, a Git something, trigger an action, right? So you have in the GitOps approach, you have at least two repo. One is the source, the application repo, and one is the config repo, the manifest repo. So this is the repo of your app, and this is the repo for the manifest describing your app. And with all the things, like my app is using Kafka, so I'm storing Kafka manifest here. If I need to perform a change of Kafka, I will change this repo, and GitOps controller will push to one or more cluster connected. But you know what? It's gonna also pull for this cluster. So if anyone changed something on the cluster and it's not expected, the GitOps controller is gonna roll back and push it again. So this really enable consistency. But why we're talking about GitOps and Kafka in this conference, in this talk, because we want to show you how you can get the best of the two worlds, GitOps and Kafka in Kubernetes, by adopting the GitOps approach. So the GitOps controller for you can monitor any change, detecting if any drift, take action automatically or not, you decide, and then deploy to one more cluster. This is the virtuous loop of GitOps, if you will. Now, for this demo, we're gonna use a popular open source software called Argo CD. Argo CD is a declarative GitOps continuous delivery for Kubernetes. It's help you doing the monitoring, the drift detection, the take action, the sync place. So it automatically sync configuration from Git to cluster, not only your app, but also the manifest describing your app. This tool is in charge of doing anything, but it's just one of the open source implementation out there. We're talking about this because in Red Hat, we're adopting this one, we're contributing to this one specifically, but there are also many others outside that you can try and see. The GitOps approach is universal. Argo CD also comes with a nice dashboard. We will see in a demo that lets you do granular control over sync. Hey, you can do rollback, roll forward by any Git commit. If somebody is gonna push a change at 5 p.m. on Friday, you know what? Okay, it's okay. If anything goes wrong, you can roll back by a Git commit, and everything is automated. So that's ideal, no? And for those of you aware of Kubernetes and already working with Kubernetes, Argo CD support two popular templating systems. One is Helm, one is Customized. Those are really helpful when you want to create Kubernetes deployment and you want to templatize them. It comes also with a nice dashboard. Well, you can review all your synchronization, you can review all the settings that you're doing, and this is more over the flow. Argo CD also support, works with a polling mechanism. It's gonna poll those Git repo for you, but also support a webhook mechanism, so event-driven, right? If there's any change, the webhook is gonna trigger Argo CD. Argo CD is gonna sync one or more cluster, and it has also a very nice dashboard that you can use to review anything. And we will see in the demo how it works. Hey, I was mentioning demo. Now it's time for the demo. Let me stop here the presentation, and I'm gonna go into my cluster because I want to show you this demo I was preparing. So we were talking about GitOps and Kafka. How about we create some Kafka cluster in GitOps, right? And then we perform our change in this methodology. So for this reason, I was deploying with Argo CD 3 Argo CD app. One Argo CD app is kind of an abstraction that points to a repository, and this repository contains something you wanna sync, you wanna deploy somewhere. So in this case here, if I go to this Argo CD deployed app, I'm going to this repo that was from my colleague Manuel that created this awesome demo, and I'm telling, hey, go to this repo, go to this branch, go to this path, and please deploy anything here. So if you click here, this is an Helm chart, and this Helm chart essentially what it does is installing Kafka in the cluster. As you can see, this is a Kafka cluster with the Helm templating system, so there's some placeholder, and here we are essentially creating the cluster with some authentication. We are exposing some port. We are defining some setting like replication factor, partition, auto create topics, not true or false, log retention, all those settings that maybe are complicated. We are putting it in a declarative way. That's why in Kubernetes anything is declarative. This one is an API, and we're using this API through this YAML because there's an operator bringing this custom resource definition for us. And I can be really granular. In this case, we're using ZooKeeper, but here's the liveness probe, readiness probe, the metrics. If we want to export some metrics with Prometheus exporter, we can give some settings. So how this works? Well, if you want to get started on this, I suggest you to go to this website, Operator Hub. First, you install the operator for Kafka. This website, operatorhub.io, give you the access to many operators for Kubernetes. You just look for Kafka here, and Strimzi is this operator I was talking to you about. Once you install Strimzi in your cluster, then you have access to the API to creating cluster. You can create a Kafka cluster, a Kafka node pool, a Kafka connect, Kafka mirror maker, right? If you want to exchange data, Kafka bridge, a Kafka topic either is an object that you can create with YAML and Kubernetes, a Kafka user. So those are API brought by the operator, which has this capability, support the install, the seamless upgrade, full lifecycle, deep insight. So you want to upgrade Kafka from 3.4.0 to 3.4.1. Well, you use the operator, you don't have to do manually, and those are the settings available. And I was installing in my cluster, so let me go to my cluster, and maybe I can remove this. Okay, let me go to my cluster. This is my cluster. Is an OpenShift cluster. OpenShift is Red Hat Enterprise Kubernetes, and I was installing the Kafka operator here. You see this name, MQStream, is just the product name behind the community version, but this essentially is the supported version of Strimzi by Red Hat. But the thing is the same. When I install the operator, I have all those API available, and I can install one or more Kafka cluster in my cluster. And if I click here, I have some insight of this cluster. Like this is a Kafka cluster, this is the version with 3 pods, and this is the memory, CPU, and I have a list of, the operator take care also of the creating secrets, creating any other things like the config map, but essentially it's just a YAML file that you can create manually, or better, you can create with GitOps. So that's why here with GitOps, we just created this Kafka cluster, and the Kafka cluster was created with some settings. Now, where are those settings? Again, those settings are on Git. So here's the Kafka cluster, here's the Kafka topic. The Kafka topic is also something you put on Git. Let me show you the same thing. Now, if I go to the same repo, and I go to this other Helm chart, here I have my Kafka topics. It's just a YAML file. This is the Kafka topic. This is those are the spec. So the name is of course defined in the help chart in this case. And those are the Kafka user. For each user, I'm defining, this is a loop. For each user, I'm defining user password. So after Argo CD will sing that, I'm showing you that those users are synced also in the cluster. So this is the same thing I was showing to you. Again, template and Kafka
I'm
users.
sorry.
Please.
There is problem. We don't see your screen at the moment. We see only creator hub page.
Oh, my screen is paused. My screen is paused. Sorry about it. I don't know why. Let me resume streaming. One sec. My screen is paused. Um, I I'll start again. One second. Something wrong happened. I don't know what. How about now? Can you see my screen?
Yes, perfect. Yeah.
So did you miss all the Argo CD stuff?
No.
Oh, okay.
And
So
this YAML. Well,
just the YAML, no problem. Yeah. So again, I was showing that I'm controlling from Argo CD the creation of users, topic, cluster into the cluster. So essentially, I'm using Argo CD to sync all of this, and all the user, those are Kafka user, are created from here. Those are declared here in this YAML that I'm using, and those are reflected into the target namespace. So this is the Kafka cluster. Those are my secret for the user 1, 2, 3, 4. So I have my wall, set up that I'm controlling with GitOps. But let's go into the use case of some ops configure this for me, but as a developer, let me test it. I want to test, this is, let me test. This is a producer and this is a consumer. Let's connect and let's do this test. So this is, for instance, I'm using the user one. I'm using the user one to write in the topic one, and I'm using the user two to read from this topic. So if I do hello jcon, this works because there are the settings that allows these settings, right? So you see, I'm just exchanging messages on Kafka, nothing really special. Now let's go into the settings here, and I hope I can click here without interrupting anything. Second, okay. Let's go into the settings. Here we go, and let's see which user makes what, right? So topic value, user value, those are the values. So user one can write to topic one, user two can read, user three can read, user four can read and write. So those are my policies. So again, this works. So from user one, I can write. From user for user this is user 4, I can read. So that's okay. How about I want to try another user. I want to try the user 3, and I want the user 3, I want to read. I have the command copied here just to don't lose anything. So I'm trying to let the user this user to read, and this will likely fail because I don't have the permission for that. So I'm not authorized to read this topic. So what I have to change to change this, I have to let the user tree access the shared topic. So my change here in Git is gonna be, so user tree can read the shared topic one. So I'm using Git to change this section. Now I can, the good thing, the best approach is to create a pull request so somebody can review it, right? You create a pull request, you ask for this security setting to change, and then somebody's gonna review and do. Now, since I'm the author, I'm the approver and the committer, doesn't make change for me to do that, but I'm just changing this value. Let me go back, show you here in the topic that there is a Argo CD is gonna also refresh all the settings here, and for the user is gonna refresh and sync again. Now, I just read my commits and apply this change. Now, if everything is fine, we should be able to read this topic because we changed this. So we are able to read because we did this change in the settings. As you can see, we can read, there's no error anymore. So we can read from the topic, from shared topic 1. So if we go back to the previous one and we write again, there's another Kafka consumer here, but we don't have any error. So let me show you, sorry, because I'm creating a pod that simulates this Kafka message exchange. So I need to restart it. 1 second. Okay, so this is okay, and this is okay. Yes. So GitOps, let's see. So I can read from shared topic 1 from my user, and you can see that now this is a producer, this is the consumer. The consumer can read because there was a change in Git that was working. Argo CD recognized it and was applying it. Now the ideal flow is through the pull request. Imagine you are working as a team over here, so somebody's gonna approve this, somebody's gonna review that. So somebody will likely, we did this change in the commit, but if I go back here, somebody's gonna review this change. Okay, Natale is trying to allow this user to read shared topic 1, but is not allowing this user to write on topic 1. So I'm approving it, and it's fine. This is an example of the full control you can have also on those things, which are authentication, security. Just from Git, you can propose a change. Somebody's going to review and apply to one or more cluster. Here in the example, there was just one Kafka cluster. Imagine you have multiple Kafka cluster per environment. This is fully supported by Argo CD and the GitOps approach, and actually is a very valid use case, if you will. Now that was my quick demo, and sorry if you lose my screen for a second. I hope it wasn't too much. In fact, as soon I click here somewhere, then I lose it. So I'm coming back to the slides because I want to finish this part, and then I'm available for any question that you might have. So that was a quick demo. I shared also the repo if you want to have a look. And the repo is over here. I'll put in the chat also, so you can access it. So we did this demo. We just added a new setting, or we can also add a new topic for some user. So we can do this change and do a pull request. To sum up everything, is not only the technology, but is a combination of people, process, and technology that makes a cohesive platform, right? We need the process, we need the companies to adopt GitOps, adopt cloud native, adopt this approach of declarative infrastructure, declarative setups. And then we need people. We need the DevOps, platform engineer. We need them work together. That's why we think this approach is a enable collaboration. Hey, if you are interested in knowing more about GitOps, you can download for free this book. This is the GitOps book. I have it here in my behind my shoulder, and it's a guide from zero to hero for GitOps, really starting from Git, and then containers, and then customize, and then Helm, and then pipelines, and then Argo CD and GitOps with also advanced use case. If you want to have a look, please go to this link, this website, You have the QR code, you have the link in the slide, and you can download this book for free. So that was my book pitch. Another pitch I have for you. You are interested in knowing more Kafka, Kubernetes, OpenShift, and GitOps. Developers.com is the best way to go. We have tutorials, blogs, video, learning, anything, and you can try also this stuff for free with our OpenShift Sandbox free Kubernetes cluster on cloud that we can provide for you. So that was my session, and I'm available for any question. Thank you.
Okay, thank you for your insights. Also, thank you for stepping in for Alex. Are there any questions?
Yes, I have a question. Do you hear me well?
Yes.
Okay, so basically we have in our company, which is Deutsche Bank, we have a Kubernetes cluster which is separated from each other. So probably we can't use the Strimzi operators, which perfectly works for a single cluster, but since we have many of them, it's really tricky to uh, to use this Strimzi. And maybe you have something in your mind how we could use this way. And uh, yeah. And another question would be, are you using ZooKeeper with Kafka or Kiraft?
Say the other, what is the last question? Sorry.
It's about ZooKeeper and Kiraft, which is better for you.
So for the first one, you told me that you have multiple Kubernetes cluster, but you don't find ideal having one Kafka cluster per cluster. Maybe you want, I don't know, you were thinking of just one Kafka cluster in one cluster serving all the other clusters, or you were thinking about any cloud solution for that?
Yeah, we're thinking about how we could create high availability cluster in case, for example, one cluster goes down, for example, something goes wrong with network, then we should switch to another one. And so what could be solution for that?
Well, that's a good point. I mean, data replication and this can be implemented and supported in a high availability environment. When you use the Strimzi is a community version, but when you use the MQ streams, for instance, for Red Hat, we support those failovers, high availability. Also, streams support those things, but if you are looking for enterprise support, then Red Hat can provide enterprise support for these use cases. Essentially, you can do the failover between the clusters, right? And there should be some data replication in progress. That's why you can use Kafka Mirror Maker to stream and replicate the data. So this process should be in sync. Think about, you have 2 or 3 clusters that you wanna replicate in order to have the high availability. It's a setup that you can absolutely do. And if you want the enterprise full support, then Red Hat support this setup. Otherwise, for the community one with Strimzi, you can implement it also yourself. You just make sure that the data replication is in place. In front of the Kafka cluster, you put something like something in front that can balance the traffic, some VIP, right? That can moves and works like that. I don't know what kind of setup you have. You have to configure two things. One is the storage replication, and the second is the network in front of your Kafka cluster to make it reliable. But it's totally doable. I think it's a very valid architecture and use case.
Yes, thank you very much for insights.
Yeah, I'm happy to share more insights. We can connect in LinkedIn or Twitter, whatever. I can send you more links on this topic.
Yes, sure. Thank you.
And I forgot your second question, of course. Can you please repeat?
Yeah, it was about Kraft. Is it prod ready? Do you use ZooKeeper still in Red Hat?
kubectl?
No, Kraft. It's like
Raft.
consensus protocol. Yeah.
Protocol. Yeah. So Strimzi, Strimzi is working also in this part. So Raft, using the Raft protocol. I don't have the latest insight of the next of the development on that, but I know that they're supporting it. They're going to support it. So definitely it's to keep they are on the right pace of the community and upstream for Apache Kafka. So anything you have there, which is community upstream, then it's gonna be included into Strimzi as soon as possible. But they were already start working on it.
Thank you.
Thank you for your questions.
All right, so we have another question in the chat. I will read it out loud. So it is, what is the resource footprint of this operator? How much resources are required? What is the minimum resource usage, nodes, memories, etc.?
That's a very good question. And I also saw in the chat there's one of the author of Strimzi, which is Paolo. So if you want more advanced insight, Paolo is the author, so I can give you more. But on this is a very good question, because when you install this operator is in charge installing your Kafka cluster. Now, for instance, I have a setup where I have a multiple Kafka clusters, and I had to tune this operator to support this multiple Kafka cluster setup. By default, the operator comes with a set of CPU RAM resource. It's called, limits and resource. It's there's some setup. I can't recall the exact amount of RAM, but there's some setup. If you have to relax these settings, you can do at ease by the subscription object into the operator. So when you use the operator, there's another API called subscription. In that object, you can say, okay, this operator should use this RAM, this CPU, and you'll notice this is necessary, because if you have multiple Kafka cluster in one cluster, then this operator has to reconcile all those clusters, make sure that they are in sync. So there's a complexity for the operator in terms of resource management. So the heap space is a Java operator. That's why Paolo is here also in the chat. It's a Java operator, so need to is using the Java heap space. You need to make sure that the Java heap space is fine with all the setup of the cluster. To give you an idea, I have in my cluster 15 Kafka cluster, and I had to increase the heap size, doubling it, because my Kafka cluster were also with lots of data, lots of topic users. So it's something to take in consideration. So the minimum resource is in the default Khalid, but if you want to scale it, you have to increase this setting in the operator subscription. This is the name of this API. I'm happy to share an example, admin, LinkedIn, Twitter, and happy to send you something.